All right, good afternoon, everyone. Welcome to Thursday, week 2. I hope you're somewhere dry, warm, and comfortably working on uni stuff. Uh, Tom has just joined us, I think. Tom, are you there?
Good afternoon. Hello.
Oh, I haven't got you coming through the right way. Sorry, bear with me while we get Tom. Oh no, that should be. Oh. There we go. All right,
Is that
Tom
better?
now should. Yeah, we should all now be able to hear Tom as well. Good
Wonderful.
afternoon, Tom. All right, good afternoon, everyone. All right, so today's is a great lecture because we introduced loops, which was really make learning to code worthwhile, and they're not that hard a concept. Well, they're not that hard concept to get started on, but they enable you to do all sorts of things in all sorts of ways. They just open a world of possibilities with coding. And I would say, yeah, this week's lab, there's a bit to do in this week's lab, and the challenge exercises are sort of weird logic puzzles, particularly the last one. But next week's lab is a lot of serious coding. So yeah, be prepared to be put in a lot of work with next week, where you start to explore while loops, and there is so much to do and so much to learn. All right, but it is so worth knowing. I'm going to do a little bit of a recap. So hopefully you've all found your way to Tutes and Labs. There are one or two people who have just joined us, but the last people I'm hoping are in the course. And I'm hoping people who we all got confused and lost in week 1. I'm hoping everyone's found their tutor, and their tutors are helping you sort out particularly how to get set up so you can, from the comfort of your own home, even the comfort of your own bedroom maybe, can code. And the easiest way is VLab. So hopefully you're set up if you have a laptop to code from VLab. If you're not, that's a priority. You have to be set up so you can work on tute questions, lab exercises before the lab, after the lab. You have to be set up. You're going to have to do a lot of coding in this course. People not having the illusion that anyone learns this stuff easily or quickly. No, you learn it in doing a lot. Now, some of us just absolutely love coding, and we happily will spend hours and hours when we've got some free time coding, and we get better at coding as a consequence. People who hate coding, if they spend all that extra time, would probably be good at coding as well, but they don't. So everyone has to practice. Just some of us really enjoy it and do lots of practice. Hopefully you're in the camp that really enjoys it. And I've said, even if you're discovering in this course that working with code isn't for you, it's a crucial knowledge for working with computers, and you almost certainly end up working with computers one way or another in future things you want to do. Right, let's recap. Tuesday, we saw if statements, which hopefully you're getting on top of. This was a nice example. I think we put it on just at the finish of the lecture. The crucial thing here is an if used to decide in our program execution. We've got two values from a user. Got the user to enter two values into two variables, rest mass and velocity. And we've computed their ratio to do a little bit of physics, and then we make a decision. If their ratio says they're going faster than the speed of light, we say, oh, sorry, we can't do anything for you. Otherwise, we compute this. You're wondering why about this? It's sort of interesting coding this up. I talked about this. If you're doing physics and maths, often coding stuff up is really interesting because you understand it. What happens here? If the ratio is greater than 1, then this would become negative. And square roots of negative numbers, my maths lecturer talked about them, but I've really forgotten what they said. But I know there is some issue with square roots of negative numbers. Actually, those of you electrical engineers, square roots of negative numbers will be the stuff of your life for the next few years. The rest of us are a little scared of square roots of negative numbers. Alright, so that's a nice little bit of code showing you a simple if statement. We did show you more complicated ones. I just wanted to show you one or two of those examples. And they take various forms. And you may think, oh, I know this, but make sure you do. Get these code examples, run them, make sure these code examples behave exactly as you expect. So there's a little chain of if statements. And a very topical chain of if statements looking at the weather. Yeah. Well, on this subject, you could take this program and you could code in wind chill. You could get the user to enter wind speed here, and then work out the wind chill. There must be a formula somewhere for you could Google the formula for wind chill, and then adjust this to give a compensated parallel advice. So I'll leave that as an exercise for you. This one we didn't cover. All right, so I'm not going to talk about this program much at length, but it's nice to recap because we introduced these sort of more complicated things. Okay, so less than, greater than equal to. They're the stuff of high school maths. So hopefully they don't scare you. And or and not. These three logical operators we introduced. You don't use this so much in high schoolish maths. They're very much the stuff of mathematicians, but you don't get exposed to them so early in your mathematical career. But here we use to say, is x greater than or equal to 10 and x less than 100 to specify a range. You're thinking, you might have specified ranged in high school maths, but you used a special notation. C doesn't have a special notation for a range. You instead use the combination of a comparison, and an and to give you a range. There's no reason why C couldn't have a special notation for a range to give you to let you have an expression that was true if X was in a range. And there are programming languages that do this, but C doesn't, and lots of the languages that have copied C don't as well. So there's, what are we trying to do here? We're trying to work out how many digits are in a number. And this is pretty crude. And I've just put together 3 if statements to say if it's less than 10 or greater than minus 10, 1 digit. Similarly, if it's between 10 and 100 or minus 10 and minus 100, 2 digits. And otherwise more than 2 digits. It's not a very satisfying program. It'd be nice to do this in another way. There are 2 other ways I can think to do this, which I'll leave as exercise for you to come back with, I think. One is a loop. You're going to need more tools than we just showed you today, though, and a loop. And the other would be use your math. There's often a thing where programmers solve things by coding. And you talk to someone who knows a bit more maths and they say, oh, you could have done that with one formula, Is there a formula for number of digits? And I believe there is. And there's what's happening here? Yeah, it's interesting, isn't it? If statement inside the else part of an if statement. If statement inside if statements. Between the braces is another world. It's a completely fresh world where we can put code that stands alone. So in between the braces we can put another if statement, and in those braces there we get another little world and another little world. So we can nest statements together. We could put an if statement inside an if statement inside an if statement inside an if statement. It does get messy and hard to understand eventually. So we try not to get too nested, too complicated. And we'll show you in next week's lecture a tool to help with that. Functions, a really important tool to help with that. And this is sort of an advanced. It's a bit sad when you write advanced and you can't even spell it. Not very advanced. This one sort of side note is the and or operators are nice in that they always say they'll go left to right. They'll never look at their right hand side if they don't need to. And if we're worried, for example, about division by 0, we could write x not equal to 0 and that. Now, if you haven't coded before, you're probably completely lost about that. So yeah, you can just ignore that. That's sort of a side note. Eventually you'll realize this is a really good idea. Eventually. So don't worry about that for next week's lab. And this, this is a side note as well. This is showing you, this is talking about doubles are approximation. It's generally not a great idea to use equals with doubles. You normally want, if you want to know if 2 doubles, you normally want to know just are they really close to each other. Not you don't want to test that they're exactly the same because of this approximation with doubles. We'll see that again. You'll see that again at the start of 1521, but that's sort of a theme. Oh, that's finished up with if statements. So that's our little recap. That's what happened last episode. What happens this episode? Actually, let's show you something. I'll show you something silly before we get serious. All right. I'm here on Vlab. I've copied it. I'm working. So I'm. Oh, you can tell I don't use this window. This is XFCE as the desktop environment, which was quite popular, but it's definitely not the one I'm used to. There we go. I'm used to one called i3, which is quite a nice setup. But it's really customizable for coders, but you have to get used to it. So we can't have you spend the first 3 weeks trying to figure out how the window manager works in a course that's got 10 weeks. So we give you a window manager that just works straight away, so you can get to coding and get to the important stuff. All right, so I set this up. Oh, actually not this one. I'll just ignore perhaps that. I want to print out the first. I want to print out all the multiples of 13, the first 13 multiples of 13, 13 to 26, 39, 52, and so on. All right, that program's a bit stupid because it assumes I know the multiples of them. So I could do it with just 1,000 printfs. You're saying, can you have 1,000 printfs in a program? Yes, you can. And how long did it take me to type those in? Quite a while. Actually, we'll run it. We'll see if what 1,000 printfs do. DCC yes says yes, Andrew. That's 1,000 printfs. See, that's the compilers don't judge. They don't look at a program like that and talk back to you and say, why are you doing that? They just compile it and you run it. It's nice. Though perhaps it should be judging me for doing that. All right. Let's make the program work out if things are multiples of 13. How do you tell if a number is a multiple of 13? You'll remember the percent operator. Now, some of you have done modulo arithmetic, and percent gives you almost modulo. It's very close to modulo. If it's not a negative number, it's the same as modulo. But its percent really is better thought of as the remainder. So something percent 13 is the remainder after dividing by 13. So 1% 13, the remainder is 1. 2% 13, the remainder is 2, all the way up until I get to 12% 13 is 12, 13% 13 is 0. I can check if a number is divisible by 13 by saying, is the remainder after I divide by 13, 0. So this gives me, you're saying, isn't this a really stupid program? Yes, it is. We'll go on to much better programs. I've now got 13,000 if statements. And that did take me a long time to type in. All right, perhaps I didn't type all these if statements in. What would I do if I said you need to produce 13,000 if statements? Perhaps you'd write a program to produce a C program. You could write a program whose printfs were outputting C. And that's indeed what I did. But anyway, here's my 40,000 line C program, my 40,000 line quite stupid C program, and I'm going to compile it, and we'll find out if DCC is happy to compile 40,000 lines of C in one go. Oops, put the machine code in the file 13_B. DCC goes and I'm done. And we run it. Oh, and it prints out the same thing, all the multiples of 13. All right, but wait, I've got another stupid program for you. You're saying, why, Andrew? Why? I like these. Look at this. I've made my program a bit different. I'm using a variable. It's a great illustration of a variable. Remember we said hash defines constant, one value, always one value, never changes, one value. Variables some of the programs we've been writing, the variable only ever holds one value, but a variable can hold many values. And have I got one for you? This variable holds 13,000 different values as it executes. It starts off at 1, then on line 19 we make it 2, then on line 23 we make it 3, all the way down to line 52,015 where we make it 13,001, I think. You can do the arithmetic there. Let's go back to the top of my 50,000 line program. Yeah, don't panic. There's not going to be a lab exercise that says write a 50,000 line program. Maybe there should be, but there won't be. Every set of lines here is the same. It says add 1 to I, then check if I%13 is 0, and then print out I. And then we've got the same 4 lines, and then the same 4 lines, and then the same 4 lines. So we've got 4 lines repeated 13,000 times. Let's just verify what it does. Oh, DCC's saying it's ticking through all of that code. And it's compiled it all. 50,000 lines of code. And it produces the output we want, the first 13,000 multiples. All right, what was the point of all this? Well, yeah, this is what happens. So this is stupid. Cutting and pasting the same code over and over again is stupid. It's not viable. We can't do that. So we need some way to say, I want to do these 4 lines over and over again. And that's the topic of today's lecture. And I'll show you what it looks like. There. This. We'll come back and we're going to explain this, but there we put the 4 lines and we wrap it with code that says do these over and over and over, and that's a while loop. That's the same program. So previous program was 52,000 lines. This program 20 lines. So we're already at a win, but there's actually we've just opened a world of power, because we can do things arbitrarily. This is a fixed program. By the way, that step that you've just seen of going from 52,000 lines to 20 lines, smart compilers will actually reverse that. If you do there's a 3rd-year course on programming language implementation, and they'll tell you how sometimes if you want to produce fast machine code, you do the reverse step. But that's not really on our agenda today. That's very much a side note. All right, so let's move to some lecture slides for today. All right. Yes. So you've just seen we could copy and paste the same code over and over again, but it's a bad idea. I've also mentioned programmers don't like seeing the same code repeated multiple places in their program. It's always a recipe for problems. We like to just have the one thing done once, so we can fix if there's changes to be made. They only get made in one place, and our code doesn't get out of sync, and it's easier to read. If statements. Yeah, I think of if statements. Yeah, you may not. You probably think of them as decisions, but I think of them. An if statement allows you to execute a piece of code 0 times or 1 time. So execution will reach it and it'll execute it not, or it will be, depending on the controlling expressions. While statements are 0 or more times. They're more powerful. In fact, if you really hated if statements, you could get rid of if statements entirely and just write everything with while statements. It would be ugly and hard to read, but it's all you need theoretically. If you're happy to write messy, unpleasant, hard to read programs, you can just use while statements. Don't do that. You do have to put extra code in a while statement, so it's not a good idea, but it's mathematically complete. different looping constructs. Yes, C has a couple more looping constructs. For loops are really in C just a convenient form of doing while. From long experience with helping students learn, we know it's better if students get on top of while. Just do everything in the while, and once they're comfortable writing code with while, we'll start using for loops. Just they don't give you any more power. They're just a little more concise, a little more convenient. But because they're more concise, it's often students often get a bit more confused if they go straight to for loops. Now, what do I want? Typically, I want a loop that executes. Well, typically, no, there's no typically. There's many possibilities with loops, but the easiest possibility to understand, a really common possibility, is a loop that's going to execute a certain number of times. We might know in advance we want it to execute 15 times, or the number of times we might not know until we run our program. Maybe we run scanf and say to the user, give me a number, then we execute the loop that many times, but n times. Wow. So this is it. This is the syntax, is what you'd call this. The bones, the characters you have to put. Brace and brace, like with an if statement, to set out what code this while loop contains. Inside here we'll indent everything, we'll space it across so that's clear visually, but it's the braces that the compiler looks to. The spacing is for humans, so we'll indent the code across always. Whatever code we put in here will be run again and again and again. How many times? It's run while, yeah, no coincidence, it's run while whatever this expression is non-zero. So there's an expression there, if it's non-zero, the loop runs. So the loop will be run, expression will be checked. If it's non-zero, loop will be run, expression checked. If it's non-zero, loop run, expression checked. Almost all the time, the expression is something that depends on what's happening in here. So eventually an execution of the loop changes something and the expression becomes zero. If that's not the case, then the loop runs forever. There are programs we want to run forever. You won't be writing them in this course, I think. It's not hard to think of programs we want to run forever. If you, for example, you've got a web server, for Amazon.com, they presumably want their web server running forever. Well, I guess you look at your own computer. There's programs running when you start up your computer. You want them just to keep running, that manage the interface on your own computer. All right. There's a few what I'd call programming patterns. A programming pattern is just a particular way of writing code, and they're a way of writing code that you see over and over again. There's nothing sort of particularly special about it. It's just that it turns out a particular way of writing code will be useful over and over again, and this will carry over between programming languages. So maybe you'll learn certain ways of programming in C here, and then you'll have to do a statistics course using the language R, and the ways you've learned to write in code you can also use in R. We're going to see a couple of ways, and these get they can be stated fairly simply, but the implications can be quite complicated. A couple of ways of controlling a loop. I think today's lecture will focus on using a loop counter, just a variable that counts how many times the loop has gone round, and we use that to decide when the loop stops. We can use a variable in a different way. We can use a sentinel variable, which we just switch on and off appropriately to stop the loop. So we can have a variable which is switched on initially to start the loop and sometimes gets switched off to stop the loop. So that's a different possibility which we'll also get to see. Where am I up to? Alright, yeah, that's pretty good. Let's switch to some code. Let's switch to some code which I think I've got ready to go over here. Not that code, not that, oh no I don't, it's in a program, but I can open that program. I'm hoping loop.c. So I've started with a loop. I've got a pre-written loop. It's like those cooking shows where they say, you know, we've already done half the preparation, so you can see the interesting bit. So I've done half the preparation of this program, so we can then do some of the interesting bit. So, oh, I've got a variable there. A loop counter variable. All right, that's I would say that's not the world's best name in general. When we get the right code to solve problems, you're probably counting some concept, and you might be able to come up with them. Well, actually, that's not always true. But you try if you can use a more meaningful name. That loop counter could be used for the variable controlling any loop. So if there's a name that specifies what it is we're counting, that would be better. But we're talking abstractly here, so that's a good name. Yeah, I do keep going on about choice of names. Choosing good names is hard. You've got to practice it, and it's crucial to making your code readable. And even if you hate people, never going to show anyone else your code, there's always going to be one person reading your code, and that's you. You choose good names, and your code can make more sense to you. And you often see good programmers, and I've seen a few of them do this. They'll sit there considering things, and they'll choose a name for this and that, think that's not good, and they'll sit there choosing names, and then when they've got the right name, suddenly all the concepts of their code will clarify. Then they'll spew out 100 lines of code to sit behind an API or whatever. But it's the names that which clarify the concepts in their head. All right, so here's my while loop. Yep. Oh, it's a new keyword, isn't it? So we've seen if is a keyword, int and double, yeah, the keywords more or less. Return, definitely a keyword. Main is sort of special. On void sitting up here, which we don't know anything about as well. So now we've got while in that list. Yeah. And as promised, a brace and a brace, and I can put any code I like in there. I can put hundreds of lines in there. I've put just one line which increments the loop counter. So here's the test. And as I've said, something in the loop affects this test. The loop adds 1 to loop counter, so that's affecting that test, that controlling expression. So that controlling expression might be 1 when the loop starts, but it could eventually finish up 0. So we've got a loop that can execute, we don't know how many times, well, n times. Alright, let's compile it and see how we do. What do I call this? Loop.c? Yes, I did. Oh, by the way, if you want to know what characters I'm typing, you can see them up there. So you can see, I don't know if that's helpful or not. And you can also see that I have a magical sequence to, well, let me show you. So I put something on the screen, now I've got a special sequence to clear it, and it's appearing up there, which is of no interest to you at all, really, because you won't have your terminal set up like that. Well, I don't know. Oh, well, that's not very good. Enter n, 45. Oh, all right. So we can test if it's really doing this. What about if I put a huge n in there? 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a billion. And I think we said an int goes from possible values you can put in. It goes from positive 2 billion to negative 2 billion. So I think that's okay to put in an int. Well, we see, and look at that. My program is just spinning round. This loop is just going round and round and round and round and round and a billion times, which may take a little while. Oh, well, not that long. Interesting. So yes, that loop just did execute a billion times. This is the joy of computing. Line 15 was executed a billion times while we sat there. Now I should say DCC is designed to help beginner programmers. So it puts loads of checking into your code and runs it in quite a slow way, because its focus is helping you learn to write correct code. So there are other C compilers that would run that loop faster. Well, actually, alright, so I guess we should do something inside the loop. What we could do is, the first thing we could do is just print out the loop counter and see what's happening. Alright, so I've added a printf statement. Actually, let me show you something. I put this. Let's say I forget the \n. What do we see then? Oh, I didn't save my program. This time, oh, well, maybe I saved it, but I didn't recompile. We'll recompile. We'll execute. We'll put in for without the new line, all my output gets jumbled together there just before my prompt. 0, 1. So let's just add a new line, the special sequence, \n to the printf to say dump out a new line. I've saved my program. I haven't recompiled my program, so let's stop that. And let's run my program. Alright, so I'm going to enter 12. Now here's a tricky thing. What numbers does this print out? You're thinking, well, it's more or less 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, more or less. What you've got to be always careful in programming is that last one, off by 1. Does it print 0? Does it print start at 1? Does it finish at 11? Does it finish at 12? Does it finish at 13? So it's easy to look at this loop and think, yeah, it prints out 12-ish numbers. Exactly what numbers it prints out, well, that's a harder problem. But if you think about it, you can work it out. So loop counter gets set to 0, we come in. 0 less than n. I'm supplying 12 for n, so n is going to get 12 there. So 0 less than 12, yeah, the loop's going to execute. So the first number it's going to print out there is 0. What about the last number? You can reason about this, and a big part of this of learning to code is learning to make little reasoning steps about your code, little logical inferences. You don't have to have any formal backing. We won't teach you theorems for doing this or mechanisms for doing this. You can do COMP1511 if you want to learn those mechanisms. And I've mentioned that students have come through this course and finished up doing tasks like writing code that keeps planes in the air or pacemakers going. And if you're writing that sort of mission critical, life critical code, then you would do mathematical proofs about it. But here we can just do little reasoning steps. Can this loop, if n is 12, can this loop write out 12? Can loop counter be 12 if n is 12? What does that say there? Loop counter less than n. So my reasoning says if loop counter is 12, the loop won't execute. So the last thing the loop will write out is 11. So it'll write out 0, 1, all the way down to 11. It'll write out 12 numbers, 0 to 11. I'm going to put that to the test. And there we go. My reasoning is correct, as you'd hope, given the amount of time I've been C coding.
There are some interesting questions in the chat about what would happen if you swapped line 15
and I'd love to. I'd love to hear the questions. What was it?
What would happen if you swapped line 15 and 16? Some people were commenting on whether that would be a good idea. Whether they should do that.
Yeah, that's a nice question, because you do a lot of stuff in maths, like you do, for example, a lot of you would have done linear equations. I think that's a year 8 or 9 topic, maybe in high school. And you can reorder a system of linear equations, and it still means the same thing, doesn't it? Order doesn't mean anything. There's a lot of maths we do, particularly in the lead up to university, or even in first year university, that doesn't have this notion of ordering or state. And that was very much the big step of Alan Turing and Alonzo Church and others, and those mathematicians made, was this moving to this notion of computation, where things like order matters. So I've swapped that. Put that. All right. I'm going to try my reasoning superpowers on this. Can this loop write out 0? All right. So we start off with 0. As long as n is bigger than 0, the loop will execute. So it's possible for this program to write out nothing, isn't it? If I enter a big negative number, the program will write out nothing. And we come in here. That says loop counter is loop counter plus 1. So the first number it can write out is 1. Now, swapping these lines won't change how many times the loop can execute, but it will change what it does. Now we'll come into the loop for the last time if n is 12, and 11, loop counter will be 11, 1 will get added to it, and we'll write out 12. And next time the loop will stop. So let me save those lines. Let me see if I can manage to recompile those lines and run those lines. We'll use 12 again, and there we go. Interesting. Yeah, so order does matter.
It's also it's worth noting on that topic as well. I mean, Andrew was talking about programming patterns. One of the most common patterns that you'll see, and some of the tutors will try and beat this into even more than I think we already have, is that you've got sort of int before the loop, you've got the while loop, and then right at the end you've got some loop counter plus plus, or sometimes I plus plus, or I equals I plus 1, or loop counter equals loop counter plus 1 to make some progress. Moving the variable so that you put it at the start of the loop, though that gives you an outcome that you might want, it will actually possibly become confusing to you over time because it's not where you expect it to be. So though you get an interesting result here, it's also kind of important to note that we like having the sort of blah equals blah plus 1 line at the bottom, because that's the pattern that you'll pretty much always see. And in fact, one of the things that I often suggest students do is, before you even write anything in the middle of a while loop, make sure that you've got the variable, the condition, and the incrementation, which is kind of what we call the last step, that last little bit there. If you make sure you've got that first, then no matter what you put inside the while loop, your while loop's going to work.
So there are many correct programs. What we often reach for is the program that's most obviously correct. So we look for the most obvious, the simplest, the easiest thing we can do. The thing that'll be obvious, because that's A, we're how we're most likely to succeed, but B, if other people have to read their code, it'll be most understandable, and it's the least likely there's a subtle bug there that's going to cause us embarrassing problems. You will have seen, it was the night before last, the internet for a good part of the world, well, only 10% of the world's internet or something, shut down for a little while. Because, I don't know if it was one of the students, but it could have been one of the students that came through this course, made a slight little mistake in the config file they pushed out. Yeah, all right. So mistakes can have consequences, so we try to avoid them if we can. You won't be able to avoid making mistakes, though, in this course. All right. So first, what does this program do? Does it matter if I swap lines 16 and 18? Those are my two questions to you to consider while I make sure, no, while I save it and compile it. Oh, date argument not used by format. Well, what the hell does that mean? Oh wait, DCC is helping out here. You have more arguments in your formatted string than you have format codes. What's a format code? Ah, DCC could be clearer there. What is a format code? A format code is something like %D. I'm disappointed in DCC not giving me, these words, format code, rather than explaining %D. But anyway, what DCC is saying is, Andrew, you've put loop counter there, but there's no %D in here to write it. Do you really know what you're doing there? Strictly, you're allowed to do that, but it's pretty much a sign that you don't know what you're doing. You're saying you've added this variable to write out, but you've never given anywhere to write it out. So something's not right. There's a thing with beginner programmers. I know most of you are good, but there are some people who are a bit overconfident, and they say warning. And I say, oh yeah, well, it's a warning. I don't need to take notice of it. I'm super smart. If you're a beginner programmer, if you're basically, unless you've been programming in C for a while, a couple of years, and really understand C semantics, C meaning, much more than we teach in this course, by the time of COMP1511, you'll be getting there. But if it says warning, that really means fix this. Something's not right here. You've made a mistake, almost certainly. It's not giving you that warning for no reason. All right, so I've changed that. All I want to do there is write out an asterisk, so that makes more sense. The variable loop counter there was just a leftover from when I was modifying code. Now DCS, if I save my file. Well, that's interesting. Let's not go into what that just did. Run this. What will this write out? Every time round the loop, it'll write out an asterisk and a new line. So if I enter 13, I should get 13 asterisks and 13 new lines. So I should get something like that. Does it matter if I swap lines 16 and 18? Does order matter for those two lines? Yeah, Tom?
Yeah, some people are just getting a bit confused by the star in chat. I think it might just be worth highlighting. What we've done here is we've made an explicit decision to change our program. So what we were doing before was we were printing out numbers, and we printed out from 0 to 12. All we've decided now is, well, actually what we want to do is we want to print out different asterisks. And what we can start getting here is what we call ASCII art, or like text art.
I don't like ASCII art. I
think
that's
like ASCII art?
Well, it's I've forgotten, oxymoron. It's like military justice. Or military music. Sorry for those of you who are in the military. We will. Well, I shouldn't say that, because what do we do in next week's lab? We get sort of bits of ASCII art, don't we? How embarrassing.
We do, and in fact we did last week as well, I suppose, with the messages of the day. But the point being, we have artworks here that we're making. This is just a very simple line, but you could choose to do other different pictures that you're doing with that sort of.
So you could write
asterisks.
You could write out "Hello Andrew" 5 times, or you could go. Oh, what will happen if I do that? That's a good one. I've done that accidentally. DCC is not going to be happy, because I put in a few random ASCII characters. I'm not at all artistic, but I'm following along Tom's thought. ASCII art, making up little pictures with characters, and I accidentally typed a %. % has a special meaning. So printf is expecting %D, %LF. There's a few other percents we haven't told you about. But printf's saying, what? %up hat? What the hell's that? I don't know what that is. Alright, so let's change that to be something that doesn't have special meaning to printf. And now we'll write out some random ASCII strings. Well, they're not random.
All right. The other thing that you can compare this to, I don't know if any of you have done Facebook recently, but some of you might have seen those Facebook posts that's just like, a billion lines of people just drawing like waves, and then like the asterisks go to the left, to the right, and you keep scrolling down. They look kind of pretty. You could now try and print out Facebook posts like that if you wanted to using C. Please don't, because they're kind of annoying, but maybe you could.
Yes, I live to help students work out how to write better Facebook posts.
I'm sure.
Not a big Facebook fan, but that's okay. All right. So I can swap those two lines actually. That was my question to you. Can lines 16 and 18 be swapped? And yeah, in this case, they can be swapped without changing their meaning. It will mean print loop counter has a different value when the printf is executed, but does that matter? No, it doesn't. All right, let's print out my asterisks again. Yeah, actually, let's go to hashes then. I like hashes. There we go. We'll save that. We'll print out. And it's going to print out a column of hashes. Let's go with 8. And there we go. Column of 8 hashes. How do I make that a row of 8 hashes? So if I want a row, what do I have to do? I have to do hash, 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 and then one new line. What am I doing now? Hash new line, hash new line, hash new line. So I've got to take the printing of the new line out of the loop. So it's only done once. And that's an important thing to do. Think about when thinking about code that's in loops. How many times is it executed? If it's inside the loop, it's executed multiple times. In this case, it's n times, but it depends on how you've set up your loop. But it's executed many times. If it's outside the loop, it's executed once. So let's put it there. All right. That's pretty good. I think that will give me my n hashes in a row. All right. Let's go for 19 hash characters followed by a new line. Look at that. Right. Yeah. So you can explore. Well, no, we've got another example of this, don't we? Still to come. We'll come back to that shortly. But where we'll put a loop inside a loop. But here we have one way of controlling a loop using a variable, and we just count it up. You don't have to count up by 1. It's possible to write loops that count down or count up in steps of 2 or 4 or 10 or even multiply each time. But for now, I'd strongly advise you, if you can, to just stick with this simple form. Loop counter starts at 0 or 1 maybe, or loop counter starts at some value, stops at some value and goes up. That's so easy to think about logically, and often then you can just work out what you want to do here. Sometimes you can do a little mathematical transformation of your loop counter to get the value you need in your code there. But that's a classic while loop, superb loop, executing this n times, this once. That's looping at its simplest and finest. Let me go back to my lecture slides and see where we're up to. Yeah, there we go. Oh. All right. There's a loop that doesn't stop. Yes. I won't run this now. You can try this yourself. If you write one of these programs, don't leave it running in our servers, please. So that loop executes forever until the program is terminated somehow. The power goes off, or there are commands you can use to stop a program one way or another. but otherwise that loop just goes around forever. Well, that we just did. Oh, sentinel variable. Alright, a sentinel variable. I know a sentinel variable example. Let me code up a sentinel variable. So I'm fond of odd and even numbers. Maybe I'd like to read a series of numbers, printing out whether they're odd or even, and then have my program stop if I enter a special number. I'll enter 0 to stop my program. All right, I've got a bit of confusion here, but so let's see if we can get the basic bones of the program working. Often it's better to get the basic bones working. So I want to do many scanfs. So I'm going to actually get this code here and put it in the loop. Yeah, let's make this indent that properly. All right. And I'm not going to use a sentinel variable. Sorry, I'm not going to use a loop counter. I'll use a sentinel variable, which we'll call sentinel. Oh well. Yeah, let's chunk all of this. We don't need any of this. All right. Here's my plan. If the user enters 0 for n, I'll say print out goodbye. And I'll set the sentinel variable to 0. And that will cause the loop to stop, and then we'll get to the loop will stop, we'll get down here, and the whole program will finish. Look at that. Well, that's my grand plan. So that's a loop controlled by this variable, which doesn't count. It starts off with a value that lets the loop execute, but inside the loop, under some circumstance, we change it to a value that will stop the loop. So this condition is no longer true. So this is a really weird variable. Its only purpose is on or off. We set it to 1, which is on, to start the loop, and here we set it to 0, which is off, to stop the loop. I should save this as something else. I should save it as sentinel. I hope I'm spelling sentinel right. Alright, let's make sure I'm... Oh yeah, these are all good. Alright. Is my code correct? Oh, it is. Well, correct. It's a DCC can't spot any in C errors, but of course that's just one step. It's a valid C program. Is it the one we want? There are so many valid C programs. All right, enter N. Oh, look at this. With the scanf inside the loop, the scanf is happening multiple times. Ah. I can see there 4, 5, 6. Well, I could be here for a while. It's quite reassuring, relaxing. Just sitting here typing in integers. Integers are calming. All right. -3, -2, -1, 9. All right, we'll enter the 0. And if I've got my code right, this if will be executed because n equals 0. That's 1. It should printf goodbye. The sentinel should be 0. Then when we go round again, this whole thing is false. So the loop should exit. Have I got it right? Yes, I have. All right, that's quite nice. Let's put a payload in there. Payload, something useful. So I'm just doing this quickly. But ooh. Checking whether a number is even or odd. So this bit I would say is not part of the programming pattern, and we're talking about programming patterns. All but line 16 to 20, this loop controlled by a sentinel variable, classic programming pattern, which we have to use in quite complicated contexts. There are better ways to do many simpler loops, but this is a really powerful way to do loops. It's not necessarily the best way to do every loop, but often you have no choice. And at this stage in your learning to code, I'm not worried about you writing programs in the simplest or best way. It can be a bit discouraging. You spend ages trying to write a piece of code and you come up with 15 lines of code, and then you see your tutor can solve it in 3 lines or 5 lines. That's just standard. It's a huge victory for you to produce a working program. So it's much less important that there's a simpler working program, and then, with enough practice, a few months or a few years, you'll be writing that simpler, better code too. But just producing correct code. Have I produced valid C?
It's also worth noting that sometimes what I find is that students who've never programmed before will come up with a solution that I would never have thought of, because I'm used to, some of the people who've been programming for a while are used to the same way that we solve every problem. And so I remember seeing an assignment a few terms ago where somebody had come up with a solution. I just thought to myself, I would never have thought to do it that way. So there's a benefit to being to not having seen as much programming as well.
All right, so there we go. Printing out odd even numbers. Is 77 odd or even? Spencer's killing me. Oh, apparently it's odd. Well, let me try a really big number. All right, so you can't work that out in your head, can you? Well, you probably can, but odd. All right, so yeah, that condition there's that use of % remainder is sort of cute, isn't it? But otherwise, that's a bit stupid. But this whole pattern is really powerful, so that's quite nice. All right, so that puts us right in the middle of the lecture. So I'm going to ask Tom if there's any questions. Otherwise, we're going to come back to nested loops, putting a loop inside another loop, and we've got a lovely example to work on for that. So Tom, questions?
It would seem at the moment we're looking okay. I can't see anything that hasn't been answered already. Unless anyone wants to post anything right now, I think we're all good.
And well, they can have the break to do it. All right, so let me urge all of you to get up, stretch, adjust your focus to a different length. Maybe 5 minutes of yoga, 2 minutes of yoga, quick visit to the bathroom, whatever it is. But we'll be back in 5 minutes. All right, so talk to you then. All right, hello everyone, and welcome back. All right, so next topic is putting loops within loops. Yeah, do I have to? So on the screen is what we had before, a program that printed out in asterisks. I'd like to write it, print out a square of asterisks. So I could enter 3 and it would print out a 3 by 3 square of asterisks. Or I could enter 10 and get 100 asterisks. Can I do that? So that's what I'd get for 3. And yes, I can. Let's change my comment. But I'm going to need to put a loop inside a loop. Now, what's here inside those braces is its own little world. I can put whatever I like in there, and I could put 100 lines of code. I could write a stupid program that had 50,000 lines of code in there. It's a separate little world where I can start again and write more code. So what I can do inside there is put another loop. So let's try that out. So just put another loop in there. Now, a big trap is don't use the same loop counter variable to control 2 loops. This always ends in, well, almost always ends in tears for students. It's just about the most common bug we see in this part of learning to write code is you get confused, or you accidentally use the same loop counter twice, or you don't understand you need 2 different loop counters. So we need a different variable. We'll start off, we'll call that one loop counter 1. It's not the best name. So we're going to use another loop counter 2. And we'll make this less than 4, say. But we can write the same style loop in here. What's that style loop? Declare the variable, so we'll do that. Give it the starting value for loop counter 2, declare it, and there. Notice in line 19 it's inside a while loop, but I can create a new variable inside a while loop, and it only exists inside that while loop. You can't actually access that variable outside the while loop. It doesn't exist outside the while loop. Inside the while loop, its own little world. Strictly, it's the braces that are really the thing. Between the braces is its own little world. And that's very important for being able to write programs easily and being able to understand and read programs easily. So, oops. I'm going to make a few changes to this program. Well, why is that? What's happening? Oh, we've got a. Okay, I'm not sure what's happening there, but there we go. All right. So that's my loop set up there. I'm not doing anything inside the loop. So it's so let's put the print asterisk inside the inner loop. Yeah, that's not a bad program to start with. That's sort of an interesting program. So we'll read in. Yeah, it's not going to. Yeah, that's a lie now. How many asterisks does that write out? How many lines of output does that program produce? That's nice. Good question. Oh, thank you, gedit, for the silly message. So I've called this square.c. It doesn't produce a square yet. It will. It will. I should be able to compile it. And then I notice I haven't saved it since my last change. I'll save it. Compile again. Alright, enter in. I'm going to enter 7. What does that write out? It doesn't write out 7 asterisks, it writes out 28 asterisks. This loop here executes 4 times. And it's done every time we go round this outer loop. I entered 7, so the outer loop executes 7 times, and every time this loop executes 4 times. So we get multiplication happening. 7 times 4 asterisks happening. That's quite nice, isn't it? We can try this out. If we make this 10, we'll get 10 asterisks for every value of n we put in. So if I put 12 net, if I say give me enter 12, I'll get 120 asterisks. You're suddenly seeing this repetition, and we're sort of multiplying the repetition. Every time this loop goes round, this inner loop executes. How many times does it execute? Well, we can actually set this to all sorts of possibilities. There are lots of different possibilities with this. And you'll get to experiment with just the possibilities, just these sort of possibilities in next week's lab. I want a square though. How do I get a square? If I enter, say, 3, I want it to write out 3 asterisks. All right, yeah, I can see that. I can see that. If I enter 3, I want 9 asterisks, so I'll change this to be n as well. Yeah, that should work. That'll get me the right number of asterisks, I'm pretty sure. Almost to my square of asterisks. Almost. And there are 9 asterisks printed out, but there's a slight issue. What I was trying to get to, I'll scroll up a bit, I was trying to get this lovely little shape. I didn't get it. How many new lines do I need? I need 3 new lines. How many new lines does this program write out? So that's the sort of question your tutor will ask you, because asking yourself that sort of question is a key part of learning to code. I look at line 28. How many times is that executed? Well, is it in a loop? Is it inside an if statement? Nope. Well, as long as this program gets to line 28, it's executed once and only once. So as long as this program, I'd say, terminates, it's executed once. You can reason about those loops and you can determine whether the program terminates. Though that famously is a very difficult problem. I keep talking about Alan Turing's achievements in the 1930s. He showed in the 1930s, before we had computers, that the question about deciding whether a piece of code like this, deciding whether we got to line 28 or not, in general, this problem is undecidable. Now, in many cases, hopefully in the sort of code you're writing cases in 1511, it is decidable. So hopefully for the sort of programs you're writing, it's decidable, but in general, no, it's not. Interesting, but all right, that's a big side note. All right, so I'm trying to mention how you're taking steps into this amazing world of computation with lots of possibilities, with these philosophers saying this changed the view of mankind's view of the universe. The notion that you couldn't look at lines 17 to 27 and decide whether you got to line 28. The fact notion that this was undecidable, was a proposition that philosophers think was, fundamentally changed our thoughts about the structure of knowledge. All right, let's go back to much more mundane things. This is executed once. How many times do I want it executed? If I want my lovely 3x3 square executed, it has to be done 3 times. So it's clear I've got something wrong. If I think about it, I've got a few places to put it. I could take it out of there and I can put it here. How many times will that get executed if n is 3? It'll get executed 9 times. So just thinking about it, I can say, oh no, that's not where I want it. That'll give me 9 new lines. That's not what I want. So I don't want that. What do I want? Maybe that. I'm really thinking that. How many times is that line executed? 3 times. All right. How have I got it right? Oh, so close. Oh, because there's one lurking there. That's the other thing. So in my head, this program was perfect. On the screen there was an error that wasn't in my head. Beware of that. That's a common trap when you're learning. Is you've actually mastered it, you figured it out, everything's right in your head. There's just a stupid error in getting it into gedit, in getting it into the .c file. So, which is really annoying, but it's a common thing to deal with. And then we need to develop ways of discovering this, working it out. All right, so it's easy here with when it all fits there. Well, not easy, but it's simpler. But as we get to write bigger and more complicated programs, finding these errors requires a very systematic approach. Important skills to develop. All right, so that was an accidental bug. And I'm hoping to get my lovely square. All right, so it's you've had a stressful day. Lots of maths lectures are difficult. Things are worrying you. You've now got a program that can print out a calming square of asterisks for you. You want a square of 9 asterisks. There you go. 81 asterisks. Well, let's try again. How about 144 asterisks? How about 400 asterisks? There we go. Beautiful. It's saying, can I write programs like this, but even more pretty and more complicated? Next week's lab exercises are for you. Coding up this sort of thing. Lovely things to play with because we can see the result visually and develop our programming skills when we have to do things that where the output's more complicated and hard to understand. These are deliberately chosen for lab exercises because it's so easy to see what's happening with your program in terms of the output. If this was a complicated calculation producing just one number, it's harder to see if it's right or not. I wanted to make some corrections to this program. Loop counter 1, loop counter 2. I said, yeah, don't call your variable loop counter if you can come up with something better. And I can. So my thought is call this one, it's counting across, I'd call them the columns of the line. So I'm going to call that column. Oh, there's a change I want to show you here as well. I've made that change to column. And I think that's still the same program. And I'd call this is counting up the rows. We write out row 1, row 2. So I'll call this row. You can call it row counter if you wanted or something like this, but I'm just going to call it row. You won't get criticism from tutors for calling variables longer names generally. Generally students choose too short a name. Alright, so that's the same program. So the compiler it just says variable 1, variable 2, variable 3. It doesn't really care what the name is. But to a human, I think that's better. I think that's easier to read. It's easy. Loop counter 1 and loop counter 2 were such similar names. Visually, they looked almost identical. You had to go through LOOP underscore CONUNTER 1 or 2. The difference was just that 10th character, whatever it was. So that's better. That's more readable. But let's see. Make sure we haven't lost our beautiful asterisks. No, still good. All right. One more thing I wanted to show you with this program. There is a shorthand for that, and if you're looking at tutorials, resources, and things online, you'll often see this shorthand. You don't have to use it. I may not use it. Well, you'll find your tutors certainly use it accidentally, but the shorthand for column is column plus 1. Such a common thing to write in programs that the designer of C says, "Oh, we'll give people a easier way to write that, a quicker way to write that." So plus plus means the same thing. That means add 1 to the variable, increment the variable. So there we go. That's the same program, but written using plus plus to say row equals row plus 1. Saves a few characters. Once you're used to that, after you've been reading that for a few weeks, maybe more, it becomes more readable to see a plus plus. Right now it's probably confusing, but I'm giving you that confusion just because I think you're gonna see lots of code like that if you go beyond the course. Alright, we're going to change topic now. I'll change code now. If there are questions, Tom, in the chat or anything I should cover, now would be a good time. Just going to go back to dice rolls.
There is one interesting one which just came up, which is like, is there like a row plus plus, but one that like increments by 2? They suggest maybe it would be like plus 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 or something. But is there something like that we could look at?
Yes, there is. There's one we'll use probably less, which is plus equals. Is that increments by 2. For those of you who love Python and who doesn't, actually, Tom and I know someone who doesn't. One of our, but
I know at least one person who doesn't. But yeah,
there's one person, a friend of Tom and I's, who's particularly vehement in his not love of Python, but I love Python. Plus equals is in Python, by the way. Plus plus isn't, because Guido, see, everyone has opinions. The author of Python didn't like plus plus, so he didn't put plus plus in Python, but he did like plus equals. There's no accounting for these things. But to answer the questions, yes, you can say plus equals 2. That gets actually quite useful if this is complicated, which is not something we've seen, but we are getting there. We're getting there. We'll get into arrays next week, and that becomes more interesting. And but you're doing that. I've messed up my. Oh, all right. Let's save that. That was a good question. Let's switch to dice rolls. Now, what I want to do is something with dice rolls. I want to work out with dice rolls, what's the chance of me rolling a particular sum? I roll 2 dice. What's the chance of me rolling a 15 or a 7 or something like this? And you're saying, what? Well, I don't think we should stick with 2-sided dice. So I think we should, 6-sided dice. I think we should let the user enter the number of sides of the dice and then work out what the probability is. I roll a 20-sided dice and a 10-sided dice. What's the chance they'll sum to 12? So let's work on this. Now, what I've done here, by the way, is I've taken this previous example where we worked out, what was this one? Oh, where the user entered 2 die and tried to work out, we worked out whether they sum to the target. So I thought, oh, well, that'll have some of the code I need. So I'll start with that. You'll see that a lot with lab exercises. So it gives you a way to start with this. I don't think I need any of these. I will need two variables, but now they're going to be quite different concepts. They're going to be the size of the dice, or sides. We call it sides. I'll go with sides. How many sides dice 1 has? How many sides dice 2 has? All right. This is, I'm showing this. This is a classic thing to do. You're going through. Oh, input validation. Yeah, I'm going to leave that for later. Yeah, no, because we're interested in loops today, I'm not going to worry about input validation. That's not to say that's not important, but all right. So we've got, that's our input done. No, none of this is good. Oh well, it's a start though. A while loop. Well, it's going to be a while loop inside a while loop. I want to go through all the possibilities of the two dice rolls. Two loops. So I'm going to need two loop variables. So let's fill this out. Dice 1 and dice 2. Oh, yeah, we're going to start them off at 1, I guess. Yeah, interesting. I guess we're assuming the dice is numbered 1 to n. Yeah, that's an interesting thought. There probably should be a comment up there. Assumptions like that are the best things to put in your comments. What do you say? Die faces? Any assumptions? What about my loops? Ooh. We could call it, yeah. I get confused about what's the singular and what's the plural. Feel free to correct me in the chat, which I won't see, but it may make you feel better. All right. That's some of the easy part. There's all the structure, the layout, the plan of my program. I've still got some bits to fill in here. Yeah. Right. And we're interested in the total, so let's declare a total, and we can just put the value in it straight away. Okay, that's good. And let's do a printf and just print them all out. %d, total, %d, and a new line. I'm flying here. All right. Now, you remember I said my task was to find out the chances of a particular sum. But the other thing I said is, and I'll keep saying this, is if you can spot a subtask, a first step, get that working first, compile, run, find any typing mistakes, find any conceptual mistakes, get it all working, and then move on from that stepping stone, make incremental processes. And that's not just a beginner programmer thing. I was working on something yesterday, talking to scripting a nasty web interface, and you'd just move in. You wouldn't write the whole thing. You'd try and get one bit working, then the next bit working. If you try and get a whole mess of code working simultaneously, you're fighting bugs in all sorts of places. So let's just see if... Oh, and there's a spelling mistake there I've already spotted. So this is meant to print out all possible die rolls after the user enters how many sides on the dice. Let's find out how many mistakes I've made in this program. I'm betting people are pointing out mistakes in the chat, and I'm not going to list them. You ignore the haters. That's what I say. These people who think my program's incorrect. Actually, my program is incorrect, but that makes it worse. There's nothing worse than a person who's spotted correctly a mistake you've made. Though we should put our ego aside and listen to them. All right. Let's go with just 6-sided dice, both of them. Popular number of sides for... Oh, my message is a bit inconsistent. Yeah, one thing you'll notice about programmers, they're quite compulsive about getting things consistently. It's good habits. It's very good habits. In other parts of your life, it may not be a good habit. Programming, it definitely is. It's great attention to finicky detail. Right, so this is meant to print out all the possibilities for a 6-sided dice. So I can roll a 1, 2, 3, 4, 5, or 6. So it's not coming up with the possibility of a 6-sided dice coming up with a 6. Where did I go wrong? And this is time and again. This is the mistake we just keep making over and over again. Getting loops like this exactly right. So it's more or less the right loop. It's just what we'd say the boundary condition is often you hear what you haven't got the boundary condition right, or it's off by one error. How do I fix that? This says while die 1 less than die 1 sides. Die 1 sides is 6. I want the loop to execute for die 1 being 6. Similarly, die 2 being 6, I want this loop to execute for. There are an endless number of ways to write this. Oh, come on, why aren't you clearing away that stuff? All right. I've got to. Okay. Bear with me. But the easiest thing is to make that a less than equal. Let's save that. Compile that. Oh my god, so many mistakes. Right, now remember, some of these errors down here you don't want to look at. Some of them may be the compiler getting confused. You just make a mistake here and then it gets confused about perfectly good code further down because it's gone on the wrong track. So start with the first error. It's saying I've made a mistake there, and yes I have. Okay, actually, excuse me a second while I see if I can get... well, let's fix that, hopefully. Alright. I fix that mistake. So fix the first error. Come back, recompile. May well be more errors, but fix things one at a time. Take steps towards... Oh, I made the spelling mistake twice. That would be sad. Alright, program that compiles. Alright, 6 sides, 6 sides. Alright. It's now printing out all possible dice sides. Let's try with the different sides. Let's try a 3-sided, no, a 3-sided dice, a 4-sided dice, and a 8-sided dice. Is that all the possibilities? Yes, it is. Alright. That's nice. So that's a program that goes through all combinations, I think is what a maths lecture, a discrete maths lecture I might call it, of two 4-sided dice and an 8-sided dice. Beautiful. Right, so we're interested in, so this is a step towards my problem. So we want to work out the probability of rolling a particular target. So we need to really read the target from the user. So let's get that there and do that. And read that in a variable called target. We better declare that variable or the compiler will be unhappy. And it's an int variable. Yeah, everything here is ints, by the way. We're whole numbers. You don't roll a die and get a fractional. Well, I guess you could if you ended on its side maybe, but we roll again in that circumstance. Yeah, the result of a successful die roll is 1 or a 6, but it's not 1.35. So ints for everything. We read in the target, and let's only print out the number if we've got the target. Let's see if we can just select the successful dice rolls and see if that's good. If total equals target. So, oh yeah, we're really going for it here. We've got, look at that. I have a while loop. While loop 1. Inside it is while loop 2. Inside while loop 2 is an if statement. 3 levels deep. I'm hoping that why has that stopped working for me? Bear with me. Oh, I think. No? Sorry, my whole setup is falling apart. Alright. So hopefully all of this together will only print out the matching rolls. So we'll save that and compile that and run it. Alright, so we'll say 6-sided dice, and print out only rolls that achieve a 9. And there we go. 3 plus 6, 9. 4 plus 5, 9. 5 plus 4, 6 plus 3, 9. Prints out the 4 rolls that gave us a 9. Alright, beautiful. So what I want is the chance of a 9. What is it? A 50% chance? Is it a 1% chance? I roll 2 6-sided dice. What's the chance of a 9? So there are two things here, and this bears nicely, by the way. You might be on top of this sort of probability, but this program actually gives you a way to explore simple probability. And there are lots of people that get confused about probability, and writing a program like this would deconfuse them. So we're working through. This is a good way to understand probability by working through all the combinations. So there are two things we're interested in: how many possible dice rolls there are, and how many successful dice rolls. And we've got points in our program where we can count those. So I can add variables, total dice rolls, and successful dice rolls. I've now got places in my program where I can increment both. In here I can say add 1 to successful dice rolls, outside here, I can do it there. As Tom said, it's better to leave the bare bones of the loop structure the same. So we'll put all of our code, not mix it up. So here we'll say, am I spelling successful properly? No, I'm not. That's probably better. Total dice rolls plus plus. All right. Now we're really interested in the ratio, the fraction, something like this. But let's start off with just printing them out, the two numbers, to see what's happening here. We'll print out successful and total. No, it's not. There we go. All right. I don't like that printf going around like that. It's probably better like that. Yeah, big printfs, it's a bit hard to format them nicely. In some cases, there's not really a hard and fast rule how you lay out things to look good when you get lines that are getting very long. But I don't mind that. That's okay. Alright, so I'm thinking I've got a program there that will count up all the dice rolls that match my target and all the dice rolls all together and give me two numbers, which will give me a chance, what my chances is of rolling a number, like 9. Why is it doing that? Alright. Recompile. Oh, no, it's a beautiful program. Why DCC? Why? Yeah, don't be that person that says DCC, it's giving me stupid errors, my code is wrong. And you've got to be careful as well. It's saying, oh look, line 25 is wrong. No, line 25 is perfect. But then you've got to be smarter. Look, warning variable successful dice rolls is uninitialized when used here. Yeah, be sure to assign a value to successful dice rolls before you start. Well, where is it assigned a value? It's never given a value before that line. So we use it here, but and add 1 to it, but it's never given a value before that. When I started out here, I didn't give it an initial value. What initial value? Yeah, when we start off, we've got no successful dice rolls. Same for total. We need to give it initial values. You might be saying, well, shouldn't C just put 0 in there automatically? Yeah, it could. There are languages that do that. C doesn't. For better or worse, you have to initialize every variable. If you like, every time you declare a variable, you can say assign 0 to it. But you've got to do that explicitly if you want to do that. It's not a bad thing to do. Why doesn't C do that? There are situations where we really don't. It creates an extra tiny. It may take an extra few picoseconds or nanoseconds, depending on your processor speed, if it automatically put a value in a variable. The code you're writing, and it's not going to matter. Code most of us are writing, it's not going to matter. If you're writing a device driver, part of an operating system or something like that, it might matter. If you're writing firmware for a chip, it might matter. Alright, dice 1 sides, 6, dice 2 sides, go with 6 and 6, target, 9, how do we go, alright, it says, my program says 36 possible rolls, down here, sorry my annotator's broken, but 36 possible rolls, of which 4 were 9s. 4 in 36. Well, yeah, maybe I can make this just a bit of text and I've got a nice program. With yet another spelling. Oh, come on, don't do that to me. Let's try that again. Look at that. 4 in 36 rolls successful. Gives me the chance of rolling a 9. It's 4 in 36. What is that as a percentage, I hear you ask? I reckon I can do that calculation. Int percentage equals successful dice rolls slash total dice rolls times 100. Yeah. So I can print that out, which is percent D percent. Let's not write a backslash B, let's write a backslash N character. Alright, that looks good. Invalid. Oh, it's that same error again. My percent here. Again, I keep going to reach for my annotator, which is not working. That percent there. That percent is printf is saying percent what? Percent backslash? What the hell's percent backslash, Andrew? But I just mean percent. How do I say to printf that's just an ordinary percent? If you say percent, printf thinks you just want percent. You say percent D, that means input an integer. You say percent LF, that means input a double. If you say percent, that means just write out a percent. I don't really mean anything special. One thing I would say, by the way, sometimes for exam questions or test questions, if the printf's tricky, we'll give you a hint and say, this is the printf, so calculate this, and this is the printf you can use, just because fiddling with printfs is not the point of the question. Alright, let's see if we got my percentage right. 6 sides, target 9. Which is 0% apparently. There's 0% chance of rolling a 9. 4 in 36 is 0%. No, it's not. So I can make my formatting prettier by jumping that. But it's going to still be the same wrong answer. While you think about it, I'll improve my formatting. Six, 9. Alright, hopefully some of you have spotted the problem. Division. We said division. I'm going to have a last chance to get my annotator working.
We're getting quite a few messages in chat letting us know that people think that there might be something wrong with integer divisions.
Good, I'm glad.
Variations on doubles, please use doubles.
I'm not going to use doubles. I don't want to use doubles. So those of you saying doubles, think of another way. Alright, everyone's pointing to that slash. And what's on the left-hand side and right-hand side? Yeah, you're doing well there. Successful dice rolls, int. Total dice rolls, int. So it's int slash int. Now, we've said there's a design choice being made. Tom and I argued about this. I've said it's pretty arbitrary. Tom says it's sort of logical, but either it doesn't really matter. Int/int gives you int in C, and not a double, and it rounds it in a weird way. It truncates it. It doesn't give you the nearest number, which you're used to, for example, getting change or something like that in the store, or your mark in the. So if you get 49.9 in this course, UNSW rounds it up to 50. You'll be pleased to know. Or if you get 84.9, it rounds up to 85. You'll be pleased to know. Let's be more positive. But C truncates. So 4 divided by 36 is 0. Oh, and my stupid annotator's still doing that. All right. So we're getting 0, then multiplying that by 100. All right. So some people are saying go to double, and I mock them, but really that's the sensible thing to do. You go into percentages. We're talking fractional numbers. You probably should be working in doubles, but there is a trick here which I'm going to resort to get something.
And
that's
which I'll note
closer.
a few people have noted that the other way of doing it as well. So you have some friends in chat.
Good. If you wanted to stay with ints, this gets you sort of close. It's better to go with doubles. But this will get you much closer. It'll give you an answer that's not as good as you can get with doubles. It's not quite right, but it's better. So I'll work out 100 times. I'll do that multiplication first, and then I'll do the integer division, which will be throwing away less. So we'll get a better answer, not a perfect. Yeah, it's an interesting thought, isn't it? You're going to get this program and experiment. We're about out of time. So those are all of you who are trying to use doubles. Yeah, that'd be a good way to improve my program. But I'm going to run it. Oh, no. What have I done wrong? I can scroll backwards. I've accidentally put a C into my program on line 18. Oh, and I have to. There you go. One message here, by the way, would be if you edit the comments in your program just before submitting the assignment you've been working on for 2 weeks, do recompile it and retest your program. It would be very sad if you've just added an accidental character which completely broke all your program. Just in the last seconds before you submit it. That would be so sad. All right, 6, target is 9, 11%. And that might be up by 1 because of what that's a bit. We could make that more accurate. You can experiment with that, put numbers in, play with that program. But the big thing I wanted to show you, with this, and I'll bump my annotator again and so it hopefully works. The big thing I want to show you is this loop structure. So this fiddling out the percentage, that's sort of a secondary issue. The big thing is this loop structure. While loop, variable, if. And this is what you get to practice in next week's lab. Now, don't panic. We're coming back for a lecture before next week's Tute Lab, and we'll show you more loops, more sentinel loops, more nested loops, more examples, talk about them more. But this program itself, it encapsulates this. Understand this. Get to a state where you could write programs like this, and that's a big part of this course, and it's an important part of learning to code. And just these skills will let you do so much. All right, I'm determined to try and not let lectures run over because I know some students have classes straight afterwards. But we've got we've got 1.5 minutes to answer any questions. If Tom has any or anything you'd like to add to this.
So there's been some discussion around %F versus %LF. People saying, "Oh, why do we have to use %LF?" I think it's worth just saying that %LF is specifically used with doubles, and that's why we use it. There are other things that might or might not work, but it's best to go with %LF because we can guarantee that it'll work.
That would be sort of a job interview question for someone who's done a degree. I would use, what's the difference between why can we use %F and %LF in C to see if they really knew the internals of C. It goes well beyond what we teach in this course. It turns out that %F and %LF do almost the same thing in printf. They don't in scanf. So you need %LF for scanf. So we just say, don't confuse yourself. Just use %LF for both, and you'll be happy. So just go with %LF.
Apart from that, I think most of the questions have been answered. Sorry to cut you off.
So I would say, if you've understood this, you haven't coded up loops before, and you've understood all of this lecture, it's pretty amazing. This stuff is not easy to learn. Most of us take longer to learn. So we'll come back to this and work through some of the things, and we go into next week's lab. We're really ramping up what you've got to do. So please try and spend some time over the weekend. Set yourself up in Vlab, get these programs, run them, play with them, start on this stuff now. Next week's when things really get quite intensive in this course. All right, so everyone, again, I hope you're all warm, dry, safe, COVID-free. Good time to be inside coding. I'll talk to you all next Tuesday as we head into what will be a big week in COMP1511. But thank you for turning up today. On those of you who are listening in to the recorded lecture, thanks for listening into the recorded lecture. And a big thank you to Tom for helping us out today as well. All right, goodbye everyone, and see you on Thursday.
Bye everyone.